Today we'll discuss ISI's 2023 UGA paper, and the first question is very simple. Here we are given an inequality which says x cube minus 7x plus 6 greater than 0. Now clearly if we put x as 1, it will be 0. So we can easily factorize this as x cube minus x minus 6x plus 6 greater than 0. Now this is x square minus 1, then minus 6, x minus 1 greater than 0. We can take x minus 1 common, so it will be this x minus 1, and here we will have x into x plus 1, so that will be x square plus x minus 6 greater than 0. We can factorize this as x minus 1, and this is x minus 2, x plus 3 greater than 0. Now the critical points are minus 3, 1 and 2. Rightmost is plus, so this plus and minus, we need greater than 0 plus, so it will be this interval and this interval. So x should lie between minus 3 and 1, or x should be greater than 2. That means the correct option is this option D. Now the second question is also very easy. It says number of consecutive zeros adjacent to digit in the units place of 401 to the power 50. Now this is a very standard question in binomial. We can write this as 1 plus 400 to the power 50. Now it will be 1 plus nx, so there will be 50 into 400 plus 50 into 49 divided by 2 into 400 square. Now this is 1 and this is 20,000 plus, and here we'll have at least 6 zeros. In the end, it'll have this 1 and then followed by 3 zeros and 2, and then there'll be other numbers. So the number of consecutive zeros adjacent to the digit in the units place, which is 1, is simply 3, and that's your option A. Now the third question is, consider a right angle triangle ABC whose hypotenuse AC is of length 1. The bisector of angle ACB intersects AB at D. If BC is of length X, then what is the length of CD? So we have this right angle triangle ABC. So this is B, this is A, and this is C. Length of AC is 1. Now it says bisector of angle ACB. So we are talking about this angle. And this is D. Now suppose this angle is theta and this angle is also theta, and it says length of BC is X. We need to find length of CD. Now if we write cos 2 theta will be simply X. Now cos 2 theta is 2 cos square theta minus 1. It will be equal to X. So we can write cos theta, it will be simply under root of X plus 1 by 2. And now in this triangle BCD, we can write X upon CD as cos theta, or CD will be X by cos theta. So we can write this as X into root 2 X plus 1. So it will be under root of 2x square upon X plus 1, and that's your option A. And question 4, we have defined a polynomial fx in terms of this determinant 1xx, x1x, and xn 1, and we have to find roots of fx. So we'll put it equals to 0. Now it's a simple symmetric determinant. So what we'll do is we'll write c1 as c1 minus c2 and c2 as c2 minus c3. So it'll be this 1 minus x, x minus 1, 0, 0, 1 minus x, x minus 1, and then it'll be this x, x and 1, and it'll be 0. Now we'll take 1 minus x common from these two columns, so it'll be 1 minus x square, and then we'll have 1 minus 1, 0, and here will be 0, 1, minus 1, and then it'll be x, x and 1 equals to 0. What we'll also do is we'll write C3 as C3 plus C2. So we can write this as 1 minus x square, and here will be 1, 0x, minus 1, 1, 1 plus x, 0, minus 1 and 0, and we'll put it equals to 0. Now we'll expand it about this third row. So we'll get this as 1 plus 2x. Will be this 1 minus x square into 1 plus 2x equals 0. So the three roots are 1, 1 and minus 1 by 2. All three of them, they are real and they have the form alpha, alpha and beta, and that's your option B. Now here the question is, let S be a set of real numbers for which this identity is valid. Now clearly this first expression on the left hand side, it's a GP and it's an infinite GP. We'll have the sum of an infinite GP if R is less than 1. So that means this cos of x, it should not be plus or minus 1. So this x, it should not be n pi. And also we have this cot x in the expression, and cot is defined only when x is unequal to n pi. So clearly domain of this question is x should not be equal to n pi. Now if x is not equal to n pi, then we can write sum of this GP, its first term is cos square x upon 1 minus r, and common ratio here is cos x. So it will be this 1 minus cos x, and it will be equal to 1 plus cos x into cot square x. Now we'll take this 1 plus cos x here. So now we can write this as cos square x upon 1 minus cos square x equals cot square x, or simply cos square x upon sin square x. So that means cot square x will be equal to cot square x, which is an identity. So this identity is true for all values of x except when x is n pi. So answer to this question is S contains all x belongs to R except x equals n pi. That means this option B. Now in question number 6, we are given two sets S and T, and it says how many elements does S and T have. So we need elements of the form xy such that x into y is 1 by 2. So we multiply them, we can write theta sine pi theta upon 1 plus theta into 1 by theta cos pi theta upon 1 plus theta will be equal to 1 by 2. Now here theta and theta will cancel. We'll take this 2 here. So here will be 2 sin theta cos theta, and there will be sin 2 theta. So we can write sin 2 pi theta upon 1 plus theta, and it is equal to 1. Now this 1 is sin pi by 2. So its general solution is 2 pi theta upon 1 plus theta, and it should be equal to 2n pi plus pi by 2. Now here pi and pi will cancel. Now we can write this as 4 theta upon 1 plus theta minus 1 equals 4n, or 3 theta minus 1 upon 1 plus theta equals 4n. Now we cross multiply, we can write 3 theta minus 1, and this is 4n plus 4n theta, or we can write 4n minus 3 theta, it is equal to minus 1 plus 4n, or this theta is 4n plus 1 upon 3 minus 4n. Now it says this theta is greater than 0. So we can write this theta, it should be greater than 0. Now we put critical points on number line. So this is minus 1 by 4, and here it is 3 by 4. Rightmost is minus. So this is minus, plus and minus. We need plus. Now this n, it must be an integer. So the only integral value here we have is n equals 0. So the only solution we'll have here is when the value of n is 0. And if we put n as 0, we'll get 4 theta equals 1 plus theta, or theta is 1 by 3. So there is only one value of theta, and that's your option B. Now in this question, what it says is how many numbers formed by rearranging these digits which are divisible by 55. Now we know if the number is divisible by 55, it has to be divisible by 5 and by 11. Divisibility by 5 is simple. Last digit has to be either 5 or 0, but there is no 0 here. So that means we have this 6-digit number and its last digit, it must be 5. So this digit, it can only be 5. Now we have to arrange these remaining 2, 3, 4, 7, 8, 5 numbers such that difference of sum at odd places and sum at even places must be a multiple of 11. Now if we look at these 6 numbers, 2, 3, 4, 7, 8 and 5. Here we have 3 even numbers and 3 odd numbers. So it doesn't matter in whichever way we pair digits of 3 and 3. One of the pair will have odd sum and the other will have even sum. So if we take all the 3 odds together, it will be odd, and all the 3 evens together, they'll be even. Or if we take 2 odds together, so suppose 3, 7 and 2, so they'll be even, and then the remaining odd will make the other one odd. So sum at even and odd places, one of them will have odd value and the other one will have an even value. So there is no point. So in no case, these two sums, they'll be equal. So we'll discard this case when this difference is 0. We have to arrange them in such a way that their difference is a multiple of 11. So the only difference possible here is 11 or minus 11. Now since we have kept 5 here, we have to arrange remaining digits so that this difference is 11, and that's only possible if we place higher digits here. So suppose 8 and 7 are interchangeably placed here, whereas 2, 3 and 4, they are placed here. Now if we take sum at odd places, it will be 2 plus 3 plus 4, it will be 9, and sum at even places, there will be 8 plus 7 plus 5, and there will be 20, and odd minus even, there will be minus 11. So in this case, this number will be divisible by 11. So that's the only case possible where the number will be divisible by 11. Now how many such numbers can be formed? Now this 5, it is fixed. We can only interchange 8 and 7. That can be done in factorial 2 ways. And here we can interchange 2, 3 and 4. They can be arranged among themselves in factorial 3 ways. So there will be simply 12. So there will be 12 such numbers, and that's your option B. Now this question number 8 is actually question of limit of sum. So what we'll do is, we'll write this as limit n tends to infinite, and this is n to the power minus 3 by 2. And here we have n plus 1, n plus 2, and 2n. So what we'll do is, we'll take n common from each of the bracket. From the first one, we'll have n to the power n plus 1. From the second one, we'll have n to the power n plus 2. And we'll go all the way up to 2n. And we can write this as 1 plus 1 by n to the power n plus 1. 1 plus 2 by n to the power n plus 2. Up to 1 plus n by n to the power 2n whole to the power 1 by n square. Now we can write this as this limit n tends to infinite. Now this is n to the power minus 3 by 2. And here this is n, and this is AP with n terms. So it will be this n by 2, and then a plus l, there will be 3n plus 1, and here we'll have 1 plus 1 by n to the power n plus 1, 1 plus 2 by n to the power n plus 2, up to 1 plus n by n to the power n plus n whole to the power 1 by n square. Now what we'll do is, we'll take this out from this bracket, then we can write this as limit n tends to infinite. Now this is n to the power minus 3 by 2, and here will be this n to the power n into 3n plus 1 by 2, and we'll also have this n square. So this n and n will cancel, and then we'll have 1 plus 1 by n to the power n plus 1, 1 plus 2 by n to the power n plus 2 up to 1 plus n by n to the power n plus n whole to the power 1 upon n square. Now, if we take them together, we can write this limit n tends to infinite. Now, it will be this minus 3n upon 2n. So, there will be n to the power 1 by 2n. And here we'll have 1 plus 1 by n to the power n plus 1, 1 plus 2 by n to the power n plus 2 up to 1 plus n by n to the power n plus n whole to the power 1 upon n square. Now in the limit of sum we have 1 upon n and not 1 upon n square. So what we'll do is we'll split it into two parts, 1 by n and 1 by n, and this one of the 1 by n we'll take it inside this bracket. So we can write this as this limit n tends to infinite n to the power 1 by 2n, and then it will be 1 plus 1 by n to the power 1 plus 1 by n, 1 plus 2 by n to the power 1 plus 2 by n, and it goes up to 1 plus n by n to the power 1 plus n by n whole to the power 1 by n. And suppose this is y. Now we'll take log both sides. Now we can write this as log y, and it will be equal to this limit n tends to infinite. Now we can write this as log n upon 2n plus, and this product will come out as summation. So it will be this limit n tends to infinite. We'll have this 1 by n, and then we'll have this summation log 1 plus r by n to the power 1 plus r by n, where r varies from 1 to n. Now this first limit, it is simple. This is infinity upon infinity form. If we use L'Hopital's rule, then we can write log n is 1 by n, and this is 2. And if we put limit n tends to infinite, it will be 0. So answer to this first part is 0. And this second part, we can change it in integral form. So we can write log y will be equal to this integral log 1 plus x to the power 1 plus x dx, and when r is 1, x is 0, and when r is n, x is 1. So it will be this log y, and it will be equal to 0 to 1, 1 plus x log 1 plus x dx. Now we'll use substitution here. We'll let 1 plus x as t, so it will be this log y, and then when x is 0, t is 1, when x is 1, this is 2, and this is t log t dt. Now this is log t, t square by 2 from 1 to 2, and then minus this integral from 1 to 2, and this is 1 by t, t square by 2 dt. Now this is log y, and here we write this as 2 log 2 minus log 1 is 0, and here will be this t by 2. So we can write this as 1 by 4 t square from 1 to 2. So it will be this log y, and we can write this as log 4, and this is minus, and this is 4 minus 1, 3. So it will be this 3 by 4. So this y, it will be e to the power log 4 into e to the power minus 3 by 4. Now e to the power log 4 is simply 4. So answer to this limit is 4 into e to the power minus 3 by 4. And that's your option D. Now this question, it says there is a triangle with the vertices 0, 0, 1, 2 and minus 4, 2. So we have our coordinate axis, and one of the point is at 0, 0, other point is at 1, 2, and another point is minus 4, 2. So this is our triangle. Now we'll write the three lengths. Now this length is under root 5. Now this is 16, and 420, which is 2 root 5, and this length here is 1 minus 4, 5. And since this line is parallel to x-axis, this distance is 2 units. Now we can simply write area of this triangle. Area of this triangle is half, and base is 5 and height is 2. So value of A is 5 and B is area of circumcircle. Now we know that radius of circumcircle is ABC upon 4 delta, and delta in this case is A. So this is 5, 2 root 5 into root 5, 4, and A here is 5. So this 5 and 5 will cancel. So this R will be 5 by 2. Area of this circumcircle will be pi r square, and that will be pi 25 by 4. Now it is asked for value of B by A. So 25 pi upon 4 divided by 5. So that will be 5 pi by 4, and that's your option B. And question number 10, we are given this series, which is this summation k varies from 0 to 202 minus 1 to the power k, 202 ck, and cos k pi by 3. Now what we'll also do is we'll consider another series, and we write this as iota p, and it'll be this summation k varies from 0 to 202 minus 1 to the power k, 202 ck, and iota sine k pi by 3. Now if we add them, we can write s plus iota p as this summation k varies from 0 to 202, and then it will be minus 1 to the power k, 202 ck, and this is cos theta plus iota sine theta, which is e to the power iota theta. So we can write this as e to the power iota pi by 3 to the power k. Now this is nothing but this is minus 1 to the power k n ck x to the power k, which is an expansion of 1 minus x to the power n. So it will be simply s plus iota p, and it will be equal to 1 minus e to the power iota pi by 3 to the power 202. Now for our series, we need to find real part. Now this is 1 minus, and e to the power pi by 3 is cos pi by 3, which is 1 by 2 plus iota sine pi by 3. So there will be minus iota root 3 by 2 to the power 202. So we can write this as 1 by 2 minus iota root 3 by 2 to the power 202. Now we'll write this number 1 by 2 minus iota root 3 by 2 in polar form. Now here r is 1 and theta is pi by 3. Now x is positive, y is negative. So it is in fourth quadrant. So its angle will be minus pi by 3. So we can write this as cos minus pi by 3 plus iota sine minus pi by 3 to the power 202. So its real part will be cos 202 pi by 3, and here it will be this minus iota sine 202 pi by 3. We are interested in its real part. So sum of this first series is cos 202 pi by 3, and that's your option C. Now in question number 11, it says, for real numbers a, b, c, d, a dash, b dash, c dash, and d dash, consider the system of equations. Now we'll consider some cases. Case 1, if a is unequal to 0 and a dash is also unequal to 0, then basically these two equations, they represent two circles. Now two circles can have no point of intersection, or they can have one point of intersection, or they can have maximum 2 points of intersection. So it could be 0, 1 or 2. It cannot be 3. Now we consider the second case when suppose a is 0 and a dash is unequal to 0. Then in that case we'll have a line and a circle. Now for a line and circle also we'll have 0 1 and 2 cases, and in the same way for an equal to 0 and a dash equal 0, again we'll have these 3 cases. So in all the cases we'll never have 3 point of intersection, so that means it can never be 3. This is option D. Now in question number 12 we are given two functions hx and fx, and it says if f dash is derivative of f, then which of the following is true. So basically we have to differentiate f dash x. So here we use Newton-Leibniz formula. So we can write f dash x and it will be this g of hx into h dash x minus g of 0, and derivative of 0 is simply 0. So basically your f dash x will be g of hx into h dash x. Now we'll have to find h dash x. Now for h dash x we have to differentiate this first function. So this h dash x will be this f, and here we have 3 to the power x, and then will be a to the power x log a minus, and then lower limit. So there will be f 2 to the power x and then 2 to the power x log 2. Now we'll substitute this expression in f dash x. So now we can write this f dash x will be this g of hx, and then we'll write derivative of h dash x, which is 3 to the power x f 3 to the power x log 3 minus 2 to the power x f 2 to the power x log 2, which is your option D. So answer to this question is this option D. And this question, it says if 4x plus 3y is divided by 7, it leaves the remainder 2, and 2x plus 4y leaves the remainder 5 and divide by 7. So we can write 4x plus 3y, it is equal to 7k1 plus 2 and 2x plus 4y, and there will be 7k2 plus 5. Now it says if 11x plus 5y is divided by 7, then the remainder equals what? What we'll do is we'll actually solve for x and y from these two equations, and from there we'll find value of this expression modulo 7. We'll multiply this with 4 and this with 3. So there'll be 16 minus 6x. So we'll get 10x, and here we'll have 7, and it'll be 4k1 minus 3k2, and this is 8 minus 15, and there'll be minus 7. Now basically 7 divides this right hand side, that means 7 should also divide 10x. So it clearly means 7 divides x. So x is a multiple of 7. Now we'll find this y modulo 7. So for this we'll multiply it with 2 and then subtract. So we get 8y minus 3y. So it will be this 5y and then 7, 2k2 minus k1, and here will be 10 minus 2, and 10 minus 2 is 8. Now we have to find the remainder when 11x plus 5y is divided by 7. Now 11x will be divisible by 7, so it will leave the remainder 0, and we know that when 5y is divided by 7, it leaves the remainder 8, and 8 is 1 modulo 7. So this expression will leave the remainder 1, and that will be your option B. Now in question number 14 it says f is a continuous function which has exactly one local maximum, then which of the following is true? Now this first one is f cannot have a local minimum. This is absolutely incorrect. We can have a cubic function which will have a local maxima as well as a local minima. So this A, it is not always true. F must have exactly one local minimum. Now that's also not true. We may have a function which may not have a minima at all. So this option B is also incorrect. Now the C is also incorrect. F must have at least 2 local minima. It may not have a minima at all. And these F must either have a global maximum or a local minimum. Now if this is the first case, then it will have a global maximum, or it is a continuous function which can have a local minima. And this function need not be differentiable. So the only correct option here is this option D. Now question number 15 is, Z is such that Z to the power 25 equals 1. Now basically this is nothing but this is 25th root of unity. Now we need to find the value of this summation. Z to the power 0, Z to the power 1 up to Z to the power 2023. Now here we have 2024 numbers, and we know that if Z to the power 25 is 1, then sum of any consecutive 25 powers will be 0. So what we'll do is we'll add Z to the power 2024 and we'll subtract Z to the power 2024. Now here it becomes 2025, which is a multiple of 25. So sum of the series, it is 0. So what will remain is this expression, which is minus Z to the power 2024. Now we can write this as minus Z to the power 2000 into Z to the power 24. Now 2000 is a multiple of 25, so it will be this one. So this value is minus Z to the power 24, and that's your option D. We have discussed all this in nth root of unity. Now in question number 16, we are given this limit, and which is 1 by x cos 1 by x minus cos x cos 1 by x minus 1. So this is a plus b minus ab minus 1. So that will be a minus 1 into 1 minus b. So we can actually write this as this limit x tends to 0, 1 minus cos x into cos 1 by x minus 1. And here we also have this 1 by x. Now I see one standard limit. So what I will do is I'll multiply it with x and divide it with x. So we can write this as this limit x tends to 0, and this is 1 minus cos x upon x square, and I'll multiply this x inside. So it will be this x cos 1 by x minus x. Now first one is the standard limit, and the answer to this standard limit is 1 by 2. And here we have this limit x tends to 0 cos 1 by x. Now this is 0 into cos infinite, and cos infinite is an oscillating value, which is oscillating between minus 1 and plus 1. So 0 into anything finite is 0, and 0 is also 0. So this is 1 by 2 into 0. So answer to this limit is 0, and that's your option A. Now question number 17 is, let n be a positive integers having 27 divisors. So we have this number n, and number of divisors of n is 27. Then product of all these 27 divisors are. Now it's a very standard theory, and the theory is product of all the divisors is n to the power number of divisors divided by 2. Whether it is even or odd, this product will be n to the power number of divisors divided by 2. So in this case, this product will be n to the power 27 by 2, and that's your option C. Now question number 18 is a simple Newton-Leibniz and differential equation question. We are given a continuous function. We need to find fx. Now if we put x as 0, we'll get this as f0. Now this integral from 0 to 0 will be 0, and then right hand side is 1. So from here we can write value of f0 is 1. Now what we'll do is we'll differentiate this expression. We can write f dash x plus log 2, and here will be this fx and will be equal to 0, or we can write f dash x upon fx will be equal to minus log 2. Now this is log fx equals minus log 2 into x plus c. Now when x is 0, y is 1. So from here we can write c as 0. So it will be this log fx, and we can write this as log 2 to the power minus x, or simply this function fx is 2 to the power minus x, or 1 by 2 to the power x, and that's your option D. Now question number 19 again is a very routine question, and we have solved n number of questions in binomial. We need to find greatest integral function of this binomial expansion of 9 plus under root 80 to the power 20. Now, if we look at this expansion, 9 plus under root 80 to the power 20, we know that it'll have an integral part plus a fractional part, and this fractional part f will lie between 0 and 1. Now we'll consider another series which is 9 minus under root 80 to the power 20. Now 9 minus under root 80, it is less than 1. So any power of a number less than 1 will also be less than 1. So it will be equal to this f, where this f will also lie between 0 and 1. Now what we'll do is we'll add these two, then we can write 9 plus under root 80 to the power 20 plus 9 minus under root 80 to the power 20, and will be equal to r plus f plus f. Now we are adding them because we need to cancel these irrational parts. So if we add a plus b and a minus b, all the odd parts of b will cancel. So we'll have an even integral value here. So this is an even integer, and we know that this r is integer. So that means this f plus f, it must also be an integer. Now if we look at f plus f, we know that value of f plus f, it lies between 0 and 2. And the only integral value between 0 and 2 is 1. So value of f plus f is 1. So from here we can write this r, it should be 9 plus under root 80 to the power 20 plus 9 minus under root 80 to the power 20 minus 1. And that's your option C. Now in question number 20, we are given a function f which is twice differentiable, and it is a 1-1 function, and it says f2 is equal to 2 and f3 equals minus 8, and we are also given that this integral from 2 to 3 fx dx is minus 3. Then we need to find this integral from minus 8 to 2 f inverse x dx. Now this question, it stems from one of the very standard result. When there used to be a subjective exam in IIT, there was this question which was to be proved. If we have a function defined from a to b and its inverse is f inverse x, then the result was this integral from a to b fx dx plus this integral from fa to fb f inverse dx, it was bfb minus afa. And I think I have solved this question in definite integral compendium. So what I'll do is, if I can find it, I'll provide the link to that question in the description below. Now in this case, f2 is 2 and f inverse 2 is also 2 and f inverse minus 8 is 3. So now we can write this integral from 2 to 3 fx dx plus this integral, now f2 is 2 and f3 is minus 8, and there will be f inverse x dx, and will be bfb, and there will be 3f3 minus 2f2. Now this is minus 3 plus this integral from minus 2 to 8 f inverse x dx. Now this is 3 and this is minus 8 and then minus 2 into 2. Now this is this integral from 2 to minus 8 f inverse x dx, and it is equal to minus 25. But we are asked from minus 8 to 2. So we'll interchange a and b, and if we do that, this minus sign will change into this plus sign. So it will be this integral from minus 8 to 2 f inverse x dx, and that will be equal to 25. So answer to this question is 25, and that's your option B. Now this question number 21 is, there are 3 left brackets and 3 right brackets, and we have to arrange them in such a way that brackets are serially connected from the left. So basically it is right use of parenthesis, and I was surprised to see this question because I have already discussed a video on Catalan numbers. And there we have also discussed the application of Catalan numbers. And this parenthesis problem, it is one of the application of Catalan number. So basically, if we have 3 left parentheses and 3 right parentheses, then number of ways in which they can be ordered correctly is given by nth Catalan number. And this is either 2ncn, n plus 1, or another way to write Catalan numbers is 2ncn minus 2ncn plus 1. Now in this case, n is 3. So this is 6c3 upon 4. Now this is 20 by 4, which is 5. And here it will be this 6c3 minus 6c4. Now 6c3 is 20 and 6c4 is 15, which again is 5. So number of ways it can be done is simply 5. And that's your option C. Interestingly, Catalan numbers, they solve a wide variety of problems. So what I'll do is I'll provide the link to that video in the description below. And even if you don't know Catalan numbers, this question can again be solved. So we have 3 left parentheses and then we have 3 right parentheses. We have to arrange them in such a way that at any position, number of left parentheses before it must be greater than or equal to number of right parentheses. So one of them could be this L, 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 R, 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 or it could be L, L, R, L, R, R, or we can write this as L, L, R, R, L, R, or we can write L, R, L, L, R, R, or it could be L, R, L, R, and L, R. So these are the only 5 cases. So either you can solve this question simply, or you can use the concept of Catalan number. Now question number 22 is again a limits question, and we are given this limit n tends to infinite, and this is 2 to the power minus 2 to the power of n plus 1 plus 2 to the power of minus 2 to the power of n minus 1 to the power 2 to the power minus n. Now what we'll do is we can write this as this limit n tends to infinite, and here we can write this as 2 to the power minus 2 to the power n into 2, and here will be this 2 to the power minus 2 to the power n into 2 to the power minus 1, and this is 2 to the power minus n. Now we see 2 to the power n everywhere, so what we'll do is we'll let 2 to the power of n as t. Now as n tends to infinite, 2 to the power n approaches infinite, that means t also approaches infinite. So we can write this limit as limit t tends to infinite. This is 2 to the power minus 2t plus 2 to the power minus t by 2, and this is 1 by t. Now are these two numbers? This is bigger. So what we'll do is we'll take this out from bracket. We can write this L, and this is limit t tends to infinite, and it'll be this 2 to the power minus t by 2 into 1 upon t, and here will be this 1 plus 2 to the power minus 2t plus t by 2 to the power 1 by t. Now here t and t will cancel, so it will be this limit t tends to infinite, and this is 2 to the power minus 1 by 2, so there will be 1 by root 2, and this is 1 plus, and here will be 2 to the power minus 3 by 2t to the power 1 upon t. Now if we put t tends to infinite, it will be this 1 by root 2, and this is 1 plus. Now 2 to the power minus infinite will be 0, and 1 upon infinite is also 0. Now in this question we are given a quarter circle OAB, and then we have the smaller circle for which OA and CD, they are tangent and length of CD is 10. We need to find area of this shaded region. What we'll do is we'll say let radius of this bigger circle be capital R and radius of this smaller circle be small r. Now we know that in this triangle OCD, this OD is capital R and this CD is 10. From here we can write this OC. So this OC will be under root of capital R square minus 10 square, which is 100. Now this OC is basically diameter of the smaller circle, which is 2r. Now we square and rearrange, we can write r square minus 4r square. It is equal to 100, and that's our first equation. Now we need to find area of this shaded region. Now area of this shaded region will be area of this quarter circle, which is 1 by 4 pi r square minus area of this smaller circle, which is simply pi r square. Now if we take pi by 4 common, then we get r square minus 4 small r square, which we already have, which is nothing but 100. So it is pi by 4 into 100, and which is nothing but 25 pi, and that's your option A. Now in this question 24, we are given this function which is defined on an Argand plane. Now this is f a plus iota b, and it is e to the power a, and here we have cos b plus iota sin b, which is e to the power iota b. So basically we can write this as e to the power a plus iota b. So essentially this function is fz equals e to the power z, which is an analytic function in a complex plane. Now we need to find whether this f is 1, 1 or on 2. Now we know that complex functions are multivalued functions. So this function e to the power z will be a multivalued function, and therefore it will be not 1, 1. And one way to look at it is in terms of this expression e to the power a into e to the power iota b. Now considering this is r, it will represent points on a circle whose distance from origin is r. So this value of b is going to cover from 0 to 2 pi, and again from 2 pi to 4 pi we'll have the same values. So for different values of b, we'll end up getting the same complex number. So being a multivalued function, it can never be a 1, 1 function. So it is many 1 function. So this function is many 1. Now what about onto? Now we can vary this e to the power a, which is r, to form different rings, and these rings, they'll cover the entire complex plane except the point origin itself, because this e to the power a, it can never be 0. So range of this complex function will be entire complex plane except 0. So that means it is an into function. So answer to this question is this function is neither 1, 1 nor onto, and that's your option D. Now in question number 25, we are given a function which is defined on a set of integers to set of integers, and it is a non-decreasing function. We are given two cases. We have to find out in which of the above cases it is necessarily true that there exists an n with fn equals n. Now first we'll take case 1. Now in case 1, we are given that f0 is 2 and f10 equals 8. We'll prove this using contradiction. So we'll say there is no n such that fn equals to n in this case 1. So we are saying that it is not necessarily true. Now if we consider numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and here we have 2, 3, 4, 5, 6, 7 and 8. Now it is given that 0 is mapped to 2 and 10 is mapped to 8. And it is a non-decreasing function. Now if it is a non-decreasing function and fn is unequal to n, then f2 will be greater than 2. That means this 2 it will be mapped with some number which is greater than 2. In the same way, F3 will be mapped with number which is greater than 3. F4 will be mapped with some number which is greater than 4. F7 will be mapped with some number which is greater than 7. That means the only option we have is this 8. And if we consider all these possibilities, and since it is a non-decreasing function, then F8 will be mapped with 8, which is a contradiction. So that means in case 1, it is necessarily true that Fn is equal to n. That means in case 1, it will always be true that Fn is equal to n for at least one n. Now let us look at this case 2. Now in this case 2, we are given that F0 is minus 2 and F10 is 12. So here we have again numbers from 0 to 10. So it will be this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And now the numbers we have is from minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 11 and 12. Now here F0 is mapped to minus 2 and F10 it is mapped to 12. Now we have to choose values such that no value is mapped to itself, and there are so many values to choose from. So it could be this function. Now this is a very simple function which is a non-decreasing function, and still Fn is not equal to n. So for the second case, it is not necessarily true that Fn is equal to n. So answer to this question will be Fn equals n is necessarily true for case 1 but not for case 2. That means this option C. Now in question number 26, we are given a cubic function and it says it has exactly 2 distinct real solutions. And if f dash x is derivative of fx, then which of the following is a possible graph of f dash x? Now it's a cubic function with an equal to 0. It can have exactly 2 distinct real solutions in 2 cases, either this first case or this second case. Now in this first case, since we are talking about graph of f dash x, function will first decrease, it will be negative, and then it will become 0, and then it will become positive, then it will become 0, again it will decrease. So graph should be in positive as well as in negative regions with 2 point of intersections with x-axis, and it doesn't matches with any of the 4 cases. And the second case is first increasing positive, then it will be 0, then negative, then again 0, and then it will be positive. So graph will be in positive and negative regions with 2 point of intersection with x-axis. So it is this graph. So it starts from positive, then negative, then 0, and again positive. So a possible graph of f dash x is this graph B. And question number 27, we are given this quadratic equation fx, which is ax square plus bx plus c, and it says this fx will lie between 0 and x minus 1 whole square. So this graph is quadratic and it is x minus 1 square, and this fx will lie between 0 and this function. So this quadratic expression will have a graph like this. Now clearly this f1, it should also be 0, and also f dash 1 should be 0, and we are also given that f3 is equal to 2. So value of f3, it must be 2. Now f1 is a plus b plus c, it is 0. Now f dash 1 is 2a plus b equals 0, and f3 is 9a plus 3b plus c equals to, now we'll subtract this first from third, we can write 8a plus 2b equals to, or 4a plus b is equal to 1. Now we're given 2a plus b is 0. So from here we'll get value of a as 1 by 2, and if A is 1 by 2, value of B is minus 1, and value of C again is 1 by 2. So it will be this option A. Now question number 28 is, this polynomial is divisible by which of the following? Now D is x to the power 5 minus 1. One of the root is x equal to 1, and if you put x as 1, remainder is not 0, so it cannot be D. Here if you put x as iota, it will be an imaginary number. C is also not true. Now if we look at x square plus x plus 1, the two roots are omega and omega square. Now if we put x as omega, we get omega to the power 10 plus omega to the power 5 plus 1, and there will be omega plus omega square plus 1, which is 0, so it satisfies this polynomial. And if we put x as omega square also, it will be omega to the power 20, omega to the power 10 plus 1. So it will be this omega square plus omega plus 1, which again is 0. So both the roots of this quadratic are also roots of this polynomial. So that means this polynomial will be divisible by A. Now in question number 29, it says, the straight line OA is given in the xy plane, make an angle theta with negative half of the x-axis. The line segment CD is of length 1, slides on xy planes in such a way that C lies on OA and D lies on x-axis. The locus of midpoint of CD is. Now since it is a locus problem, the first step is identify the point. Suppose you have to find locus of this point and say it is h comma k. Now coordinate of D is suppose alpha comma 0, and this C is suppose P comma Q. Now equation of AO will be y equals, and slope of this line is 10 pi minus theta, so it will be minus x 10 theta. So basically Q is minus P 10 theta. So coordinate of this point C will be P comma minus P 10 theta, and coordinate of this point D is suppose alpha comma 0. Now the midpoint is h and k, so P plus alpha upon 2, it is h, and minus P 10 theta upon 2, it is equal to k. So from here we can write P is minus 2k cot theta, and alpha is equal to 2h plus 2k cot theta. Now we have alpha and P in terms of h and k. Now we are given that length of CD is 1. That means CD square is alpha minus P square plus Q square, it is equal to 1. Now alpha minus P will be 2h plus 4k cot theta whole square plus Q square, and Q square is minus P 10 theta, and P is minus 2k cot theta. So that will be simply 2k square, and that should be equal to 1. Now we can write this as 4h square plus 16k square cot square theta plus 16hk cot theta plus 4k square equals 1. Now if we divide everything with 4, we can write h square plus k square 1 plus 4 cot square theta plus 4hk cot theta, and it is equal to 1 by 4. And in the end, we'll replace h with x and k with y. So this equation will be x square plus y square 1 plus 4 cot square theta plus 4xy cot theta, and will be equal to 1 by 4. And that's your option A. Now in question number 30, it says how many functions from 1 to 10 to 1 to 2000 can be formed which satisfy this property f I plus 1 minus fi, it should be greater than or equal to 20. Now what we'll do is, we have codomain of 1, 2, 3 up to 2000, And from these 2000 values, we have to select 10 values for these 10 points in the domain. So we have to select 10 values. 1, 2 to 10 values. Now if we have selected these 10 points, then basically we have partitioned this set in 11 parts. So suppose here number of elements is x1, in between these two it is x2, then we have x3, and here will be this x11 and x1 plus x2 plus x3 plus x10 plus x11. It should be equal to, now from these 2000 points we have already taken 10 points, so the remaining points are 1990. Basically x1 and x11, they can be 0, so x1 can be 0 or greater than 0, and x11 also can be 0 or greater than 0. We have solved many questions like this in permutation combination assignment. Now here the condition is fi plus 1 minus fi should be greater than or equal to 20. That means in between any two choices, suppose a and b, we know that this difference is b minus a plus 1 and it should be equal to 20. So this b minus a, it should be 19. So each of x2, x3 and x10 must be greater than or equal to 19. Now what we do in this situation? We replace xi with x dash i plus 19, where x dash i is greater than or equal to 0. So we can write x1 plus x2 dash plus x3 dash plus x10 dash plus x11, and then we have these 9 values, so there will be 9 into 19 and it is equal to 1990. So here x1 plus x2 dash plus x10 dash plus x11 will be equal to 1819. Now here we need number of non-negative integral solutions. Number of non-negative integral solutions, and is given by n plus r minus 1 c r minus 1, and in this case n is 1819 plus r is 11 minus 1 and this is 11 minus 1, so it will be this 1829 c10, and that's your option C. And we have not arranged it because fi plus 1 minus fi is positive, so it is an increasing function, so it can be arranged in only one way. So answer to this question is this option C.
Hello and welcome to the world of mathematics. I present my website www.mathsmarazine.com and my YouTube channel Mathsmarazine for your kind perusal. If you like them and are inspired by the possibilities, then consider subscribing and sharing it with someone you know who might benefit from it. Thank you.